All right, welcome to the L2 Interop Working Group. We have a few agenda items for today, starting off with updates on interoperable addresses, aka chain-specific addresses. This is ERC 7828 and 7930, presented by Unruggable and Wonderland. Next up, Open Intents Framework, some updates there, and a demo presentation overview of some work from Nethermind on OIF Starknet. And then last up, um, open discussion, many updates, comments for the work happening around the 7-day withdrawal window reductions. This is for optimistic rollups and the 7-day windows. Okay, cool. So that is an overview of the agenda, and I think we can kick things off with agenda item number one. Whoever wants to start there. Orca?
Hey, yeah, thanks. Thanks so much, Josh. I'll share some things to look at, I guess, quickly. Oh, sharing's not turned on. If you can help, Josh.
Yeah, 1 second, sorry. Okay, good to go.
Yeah, so as Josh mentioned, oh, um, this is interoperable addresses. So this has been ongoing
I
for
can't
a
see your
while.
screen just yet. Okay.
Yeah, 1 second. I'm just getting the
Oh yeah.
permission. Can you see this guy
Oh
now?
yeah, works. Thank you.
Um, So this is a site just giving an overview of some of the work which we'll be publishing. As Josh mentioned, this is chain-aware addressing for the Ethereum ecosystem. It actually, the standards allow for addressing for non-EVM chains as well. There's been collaborative effort between a bunch of people. Some of the logos are here. If your organization has been a part of it and isn't shown here, then definitely do give us a shout. In terms of why these addresses are needed, obviously, getting addresses and chains joined up in the right way is important. Wrong chain lost funds in some cases, just generally readability typos, and there's also like a reliance on a centralized chain list for a lot of information in terms of chain IDs mapping to chain names. Interoperable addresses try to address much of these in one fell swoop. So chain-specific addresses to prevent errors, powered by an on-chain registry, a compact format for use in on cross-chain messaging and intent declaration. Thinking about things like human readability and yeah, as I mentioned, universal compatibility. How does it work? Essentially, there are these two ERCs, two layers. The 7930, which is the binary representation, a simple human readable format, and 7828 wraps that in ENS for both address resolution, but then also chain name resolution. So you can put in alice.eth at base. These specifications are approaching finalization. So I think Thomas from Unruggable will talk a little bit more about where we're at with those and the status of the chain registry. And yeah, we're working on essentially tooling stuff to make this a bit more accessible and digestible. So essentially, if you look at metallic.eth, this is a demo site powered by the addresses module of the Interop SDK. It essentially breaks down and makes it easy to see, okay, if you go from this human readable address, how then that gets turned into the binary format, what the different parts are. You can see the representation there. And all this is available in the Wonderland Interop SDK and specifically the Interop addresses module. There's some FAQs there as well. But as I mentioned, we've made a lot of progress. There's still a few things remaining, which I think Thomas will talk about. And generally, we're talking to wallets about integration. We're seeing this being integrated into more and more standards. So even today, the clear signing effort, I think 7730, we were talking about this. So uh, excited to see it, I guess, approaching production. And I'll hand it over to Thomas.
Perfect. Thank you, Walker. I'm Thomas from Unruggable. We work for the ENS DAO, and we've been working extensively with the team at Wonderland on these specs. So I'm just going to give a brief update from the ENS end and from the spec end. In terms of 7930, which is the binary format, we've been iterating on the exact terminology and semantics of that specification to make it as accessible as possible. We're very close to kind of completion on that. And then we're going to be creating a pull request to get that into the actual Ethereum ERC's repo. The 7828 one adds the ENS specific functionality, which is a chain registry resolver that is the resolver for the on.eth second level ENS name. There was a temperature check posted by Josh on the ENS forum to get a read of the room if the ENS community were happy to assign ownership of on.eth to the multi-sig that will be leading that effort. I've posted that link in the chat. The general consensus from the ENS DAO was a positive one. I say the general consensus, it was completely positive. No one disagreed. Everyone was very happy with it. So in terms of next steps, I will be putting together the call data to propose an executable proposal to the ENS DAO to have that assigned to a multi-sig, which will then allow us to set the chain resolver as the resolver for that ENS name, which is the resolver through which all of this chain metadata discovery occurs. In terms of the state of that chain resolver, that repo is complete and ready to go. We had a discussion today between myself and the Wonderland team. We're just working to add some final touches, including aliases, whereby chains go by multiple identifiers in different contexts. The obvious ones being OP and Optimism, or ARB and ARB1. Such that we kind of have the functionality that those can all resolve to the same ERC 7930 identifier. Orca is piecing together kind of a finalized list of chains, their labels, and the metadata associated with those chains. The intention was that we would post that on the ENS forum as well as on ETH Magicians, and we would circulate that through social media to kind of get the eyes of chain operators on that list to make sure that everything is correct and in order. Initially, we're intending to have the administration of the resolver controlled by a multi-sig that will have representatives of Wonderland, Unruggable, the Ethereum Foundation, the ENS DAO, etc. And then over time, once this is kind of solidified and everyone's happy with the state of things, we will assign authoritative ownership to the people and representatives of the chains in question. And we will kind of remove any administrative control from that multi-sig. So at that point, the chain will own all of their metadata and all of the information associated with it. I think that is everything. Yeah, once the executable proposal is passed, we're just doing final testing of these contracts. We'll kind of test it in production on the on.eth name and make sure everything is working. Then the intention is to create pull requests to established frameworks like VM and ethers, such that we can get this integrated into clients, wallets, dApps, etc. That is all from my end. Happy to answer any questions.
Hi, this is a great update. There's just a couple questions in the chat for links to the SDK and the website for interoperable addresses. Thank you.
Yeah, Orca, do you want to drop a link? I think the website is not quite ready to be live yet. Is that correct?
Yep, that's right. We'll definitely share it, I guess, with this group when it's there. But I shared the link to the npm package.
Perfect. Any other questions? Cool. We can move on then. Next up on the agenda, OIF updates. Maybe we can start off Let's see, is Barnaby here? Are you available to chat, to talk?
Hey,
Hey.
Yep, can you hear me?
We can.
Nice. I'll show some slides just quickly, and then I'll let, I know there's other people in the room who were also part of this. So, like briefly, what happened just before DevConnect is a bunch of us went to HCT from Ethereum Foundation, Open Zeppelin, Wonderland, and many other teams, LeFi, and other teams that are now dipping their toes into the open intent framework. And the idea of this week that we spent together in Patagonia was to try to accelerate some of the integrations or components of OIF towards having an end-to-end demo of an intent that was secure and propagated through the OIF layers. And I think we made actually a lot of progress. Maybe some people will discuss some of those, but I just want to show an overview of what was built. One of the first things was a payment request demo that was actually using the interoperable addresses and OIF at the back to settle the intent. Mislav from Bioeconomy and Kaimi, they worked on cross-chain deposits using composable batching so that apps have access to a toolbox that allows them to just very easily provide interoperability tools to their users. We had some work on a compliant resolver, so using 7683, make the solver understand the orders so that you can create deeper markets with more solvers that all follow the same standard. We wanted to harden also the oracles, so propose like an optimistic game that secures an intent. So the solver wants to settle, somebody can challenge that settlement, and this is eventually resolved using the broadcaster, which is this trust minimized proof going over the canonical bridges. Someone worked on proving the fields, so instead of storage proof, using ZK proofs, which I think was really cool. And then we had another project that was mixing together AI agents, resource locks, TEs, and other like tools in one beautiful mix of all of this. I think that's it. But we had a lot of fun, and I think it was also very productive to show the promise of OIF and already what's available, which was quite a lot, like definitely sufficient for us to make a lot of progress in 3 days.
Awesome, thanks. Pepe, do you want to share anything next?
Yeah, sure. So I just want to reiterate what Barnaby just said. Like, we had a very nice time in Patagonia. I appreciate everyone who attended and everyone who supported. Since then, or like around those days, a couple of updates regarding OIF and Open Zeppelin. So the main audit of the OIF settlement contracts was released. You can find it on the OIF contracts repo. We've also audited the first part of the broadcaster protocol. So like the core contracts in broadcaster have been audited. I believe that that audit is not still fully public, but we will share relatively soon. An upcoming audit will take care of all the provers for each different network type. One of the points that was raised or was identified during the Patagonia event, it was like the fact that the solver could not support arbitrary callbacks and could not kind of support basically random actions on top of just moving tokens. There is already basically a solution for that in the solver repo. So if anyone is interested in following up, you can go and take a look. Now, what's happening, or like what are we now focusing on? We're focusing on broadcaster and evolving the provers and making sure we have like secure and compatible provers for everything. And we are focusing on onboarding the long tail of issues. So We will be able to share much more information on how we are feeling about it, but generally speaking, we've identified that the biggest requirement is basically having a solver or a solver network that supports your specific new L2, and the solver will basically be able to do self onboarding. But a lot of networks doesn't want to run that infrastructure themselves. So we are looking at ways on how to facilitate this, on how to play around with liquidity management. So yeah, it's an active point of conversation. So if any of you are interested in participating in these debates, if you know of an L2 that wants to get onboarded and is having issues with other intent providers, happy to get in touch. And then for the big question of what's being printed, it's a beer, like a wine bottle holder beer. I will send you a picture, Forrest.
Nice. Please do. I actually also have one remark that is OIF related, not just the printer behind Pepe. And that is a few days ago on the OIF drivers call, to some people's surprise, we kind of identified a potential obstacle for OIF, which is that the even I would have thought negligible gas cost increase of something like an OIF wrapper of 10K might actually be a big showstop for some solvers and even aggregators. And so I was wondering if anyone in this call had additional input on what it would take for a standard that is slightly less gas efficient to actually be more attractive to them.
I mean, my thoughts just to share with the rest is obviously much more kind of streamlined contracts will allow for optimized gas use utility. Having a standardized wrapper or layer on top of that may increase the gas cost, but will definitely increase the compatibility surface. So I think it's also worth checking, like if anyone on this call or checking the recording does have specific concerns. Worth mentioning, we've been talking with the LeFi and across teams for this, and they also have their own thoughts on different approaches for this.
Cool. I think we have a few more updates on OIF. Mislav, do you want to hop in next?
Yeah, sure. Hi, everyone. Mislav here from Bioconomy. Yeah, I actually wanted to share some slides as well, but I joined over the web Zoom, so it's not allowing me. Anyways, what we were working on, I give a shout out to Volts FYI and Kaimi, who is Anon, so we'll stop there. So the idea was that we combined the OIF 7683 with 4337 with 7579 and with a few non-ERC things, which is Bioconomy super transactions and Volts FYI call data generation, to achieve something that's kind of a big deal in DeFi, is rebalancing volts from one chain to another without any dust in between. So like the problem space that you had before was, if you like go from a USDC vault to a USDT vault, from like Arbitrum to Base, the problem is that when you unwind, maybe at that point you still have information exactly how much you're going to get from the vault. Sometimes you don't, because like linear calculations, like for curves for calculating interest rates, can mess up with you. But if you like withdraw from a vault, then you swap to another token, then you call a bridge, then you supply, approve and supply to a vault on another chain. The idea is that this should all be done in a single signature. Now, this uses, for the single signature stuff, we use the Bioconomy Merkle Tree ERC7579 validator module, which enables basically single-click execution across multiple chains. It's very, very similar in design to the Merkle Tree validator from EIL, Ethereum interoperability layer. Essentially, I think it's part of our code base that's being referenced there as well. So I'm assuming that's also something that's going to get standardized quite soon. And then we use this composable batching module, and then we used basically one of the features that I'm the happiest that OIF currently has, which is the fact that with OIF, you don't have to provide the exact same value to the function call that you quoted. For example, you quote an Ethereum, you quote moving USDC from one chain to WETH on another chain. And then you get basically quote that says like for 3,100 USDC, I'll give you one WETH or something like that. If you are essentially in a lot of like other bridges, you would have to provide the exact same value that you quoted before. But you quoted this before you started execution. So before slippages were incurred on chain, you didn't know exactly where in the block your transaction is going to get set. Maybe you get like some better, some worse execution. So you could get very, very precise. You could get within like 0.5% of precision, but you would always leave some dust. And this would incur compounding execution inefficiencies. If you had 0.3% inefficiency on every step, you would have 5 steps. It would escalate to 1.5%, and suddenly your solver or multi-chain execution aggregator is no longer competitive with anything on the market. This has made it so that right now, how these multi-chain vault optimizations are done is that solvers actually hold inventory of vault tokens often, and they will quote you for this. Oftentimes, for smaller vaults, this will result in like immense slippages, like 60%, 70%, something like that. So in this case, the only slippage we incur is the like USDC to WETH open intents framework slippage, which, you know, with the modular nature and the capital that's going to accrue there with all the big solvers, I assume there's going to be an extremely competitive rate. And all the withdraw from vault, swaps, and then supply to another vault is done through this composable batching. So it's essentially a zero slippage operation. So yeah, that's been coded in the 3 days that we were there. We did a live demo. It worked really nicely. I mean, demo is kind of janky, to be honest. It was lucky that it worked, but it demonstrated the point across. And yeah, so the idea here is also, if anyone is interested, I would like to propose, we already have the code audited, ready to go, but for people to comment and maybe make composable batching into an ERC, I would love to see it being essential part of the Ethereum stack, to be honest. It's shown itself to be immensely useful for us and our clients when used. Yeah, that's it from my end.
Thanks, Gustav. Anyone else with any updates on OIF stuff? Cool. If not, John, I think you're up next then.
Okay. Hey everybody, it's John Church, Nethermind, product lead for our institutional and DeFi and also our Starknet division. But I just wanted to showcase, you know, we were really excited about building an extension of the OIF on Starknet, and so I'll share my screen. We've built this out, a Cairo implementation of the Solidity contracts, as well as a solver in Go instead of the open intents Rust solver. So, you know, if anybody's interested in checking this out, I'm going to share this in the chat. And you know, we have the test build out. We have you know, everything fleshed out for anybody to get started, and of course a template solver. So you know, anybody would want to take this and customize it to different strategies or whatever your competitive analysis is. So and we also liked it so much that our lead dev on it took it and built a hackathon project with it and implemented it. So Matt, if you want to share off what you built.
Sure. Yeah. Hey, everybody. My name is Matt, also from Nethermind. Yep. I can share my screen here. I'm new to Zoom, so excuse. Let's see. Set permissions real quick. In order to share screen, have to quit and reopen. Is that fine, or should we just skip this?
Maybe
Yeah,
try.
yeah.
Usually you don't need to actually restart. Just try now that you've granted.
Gotcha. Oh, yeah, I think you're right. Cool. So you guys can see my screen now?
Yeah, we can.
So yeah, here is the project we built for the hackathon. The only difference between this and the one that we built for Nethermind is that we added support for the new network, like a proof of concept network called Zarknet. Zarknet, it's kind of hard to pronounce, but essentially this all runs off of that. So I've already connected an EVM wallet and a Starknet wallet. So here, I'll open up this. And then if we open up, we're also running a solver for the hackathon. So if I pull that up, now we see the logs for that. Okay, cool. So if we pick a chain, we can just show off, go to Starknet, keep it simple. For this demo, we're using just a ERC20 that we deployed. Sorry. Transaction, bridging those tokens. And then we'll see over here, we'll see the solver pick up the order and start to fill it. And with that, I mean, I can share transaction hashes, but with that, you will see that the one dog coin is now sent to the Starknet address.
So that's it. We just wanted to celebrate a win, share off how we built an implementation and the like. So it's no major protocol updates or anything like that. But we're extending OIF to Starknet and yeah, the UI was pretty cool. I thought they did a good job at that. Oh. Thanks, Matt.
No problem. How do I stop sharing? Or is it already? Oh, right here. Cool.
Love it. Super cool. Thanks, John and Matt.
Yeah. Thanks, guys.
I think it's great to see progress is progress, and it's great to see continued adoption of shared infrastructure. So yeah, thanks for coming on and sharing that. Any questions on any of that? Cool. If not, we can move on. I think we are at the final agenda item for today, which is a continued discussion of what we touched on the last call, which is the 7-day window reduction. And maybe just to set a bit of context for folks who are not familiar, I think most everyone here is, but just in case. What is this? Why do we have 7-day windows? Just really quickly. Well, and actually Dono has a great post on this. I'll link it in the chat in a second. Recommend reading for anyone interested. TLDR was originally set to allow enough time for a social response in case of any sort of attack from, let's say, malicious nodes or builders, and to prevent funds from being stolen. Downside, of course, of the 7-day window is that it's a bottleneck on UX, liquidity, assets, and just generally users' ability to seamlessly do what they want to do across chains. So there's been a bunch of discussion and renewed interest. This is not the first time this has come up, of course. It's not a sort of new piece of information. This was by design with an understanding of some of the sort of limitations. And I think there's definitely been a bit of renewed interest in seeing what we can do, given what we've learned and given what we now know around paths to reducing this to something like 1 or 2 days. I think there's fairly broad agreement that there are significant benefits. There's no disagreement that the benefits are meaningful. But at the same time, this is, of course, a sensitive area. We want to be mindful in how we approach this and not just sort of YOLO it. So yes, we've had discussions with folks from Arbitrum, Optimism, Uniswap, L2Beat around what is the right way to do this, what sort of data do we need to gather, and how can we do this in a way that of course, doesn't take months and months, but allows us to get sufficient confidence in what we're doing here. So maybe that's just, yeah, a bit of context. I see we have Ed here. Do you want to jump in with anything?
Sure. Yeah. So from my point of view, and I think our team's point of view, what we would need to justify reducing the inclusion time assumption would be some kind of analysis that shows that doing so would be safe. That is, against an adversary who is very highly motivated and capable. Can we really guarantee that a party who wants to get a transaction included on L1 Ethereum can do so within 24 hours? And in order to establish that, we need to think about sort of what assumptions can we make about Ethereum? Because I think it's easy to get to a one-day delay if you make unrealistic assumptions, right? Like an unrealistic assumption would be to assume that if I want to submit a transaction at time 0, that at time 0, it will be in the mempool of every local mempool of every builder and will stay there, even if a highly motivated and capable adversary is trying to prevent that, right? That would not be a realistic assumption to make because we know that adversaries can, in fact, mess with mempool propagation, try to destabilize the P2P network, and so on. So in order to get to any confidence in an assumption about inclusion time, which I think is what this really is about, really requires like careful analysis of all the different ways that an attacker could try to prevent inclusion of transactions. And I don't think we have anything like that kind of analysis that's been done, to my knowledge, by anybody at this point. And that's really, I think that's really the missing piece that would be needed to justify making a particular change.
Right. And just to highlight for the group, what we need to understand is what is the maximum cost to guarantee a single transaction can get in within a certain amount of time, in this case, 24 hours.
Well, the question is, can we even guarantee that at any cost? Because even that is not established.
Right.
Right. There are some, just to expand a little bit on what Josh said, there are some kinds of attacks that are economic in nature, and there may be economic responses to those attacks where honest parties could spend some money to try to sort of somehow outbid an adversary who's, let's say, bribing block builders. But there are other attacks that are not economic in nature. And this being a security property, we need to reason from a set of assumptions about what guarantees Ethereum can provide us, and then figure out, okay, given those assumptions about what Ethereum can provide, here's a procedure that we can embed in our code that would guarantee inclusion within 24 hours or 48 or whatever number we might pick.
Right.
And that's kind of, to me, that's the missing piece is, what are the assumptions about L1, and then what procedure from those assumptions can get us to a guarantee of inclusion.
So I shared in the chat some, not a full answer to this question, but some analysis that Dano from L2Beta has put together. I think, Ed, you've pointed out that this doesn't quite fully cover some of the more sort of adversarial.
Yeah.
Yeah.
Yeah. This, as I understand it, Dano's formula is based on a paper that our team published that analyzes one type of economic attack. But it's only one of the tactics that an adversary could use. And combining that tactic with other tactics means that the results of the paper don't give you any guarantee that would apply to Ethereum. Right. It's maybe a piece of the analysis that might be needed, but it doesn't cover some of the really significant potential avenues of attack.
Right. And if anyone else wants to jump into the discussion, feel free. Ed, how is your team sort of approaching next steps here then potentially? Are there folks on your side that are looking at a more thorough analysis?
The really tough part is there's a bunch of tough pieces of this. One of them is how to analyze the possibility of old school denial of service attacks, like say network flooding attacks against the party who's trying to get a transaction included. What kind of assumptions can we safely make about ordinary parties' ability to, let's say, reestablish connectivity to Ethereum if they're subject to such an attack from a highly motivated adversary? That's one piece that I think is hard to model. Another piece that I think is hard to model is P2P propagation and mempool management in clients, because clients tend to use client-specific heuristics to decide how to manage their mempool, what to keep, what to throw out when it gets full, and so on. And so if we're going to make an assumption that an honest party can keep their transaction in the mempool of all of the block builders for an extended period of time against a hostile adversary trying to prevent that, then we need to have some way of reasoning about, say, mempool maintenance policies of clients and how resistant they are to manipulative behavior by other clients. So we don't really even have a handhold on that problem, I think.
Right. Got it. Yeah, I guess I'm trying to think through then what is the sort of best path forward at this point. It might be taking it back to the group. I know, yeah, Optimism is also interested in running their own analysis on this, as well as Uniswap and potentially others. Pepe, you mentioned potentially Open Zeppelin might want to jump in and help if helpful.
Yeah, I mean, if people have analyses about, say, the impact or what we can assume about, let's call them old school denial of service attacks, or what we can assume about attacks on P2P propagation or mempool management, that would be really helpful. I think those are missing pieces, and if anybody can figure out like how to reason about the security of properties of that against an active, motivated adversary, I think that would help to fill in the gaps.
Okay, cool. That's helpful. Got it. And Ed, I'm not sure if you're the right person from your side to answer this question, but may be helpful to share sort of the latest on how your team is thinking about the alternative or another approach around accelerating something like a 2 of 3 system. I think Vitalik called it pragmatic fast finality in the past.
Right. So yeah, there's things you can do if you where you have like a ZK proving and optimistic proving, as well as some kind of, say, Security Council veto type of situation, and where you want 2 of 3 of those to happen. Now, one thing to note is that Security Council affirmative security, or let's see, so a Security Council response also relies on non-censorship, or an assumption about the Security Council's ability to include a transaction. The other thing to note is that ZK-based proving is also subject to censorship attacks. The difference is that censorship of posting a ZK proof doesn't harm the safety of the chain, but it does delay settlement. And there are realistic scenarios where a motivated adversary can delay the posting, temporarily censor the posting of a ZK proof in order to delay settlement and cross-chain interop for whatever reasons they might have. And that's another area that I think is underanalyzed, is basically attacks that aim to delay settlement as opposed to defeat it.
Right, got it.
Right, so I think even with the 2 out of 3 system, you're still subject to some censorship considerations, as well as the obvious ones around cost, the cost of posting frequently, and so on. But yeah, we're absolutely working. We, the off-chain team, in R&D are working toward a system that would be in the spirit of that 2 of 3.
And not to like hold you to any sort of specific date, of course, but how are you thinking about sort of the roadmap here? And is this like a 2026 goal further out?
We're not talking about dates. And I'm being a little cautious here because I'm not sure what we said publicly.
Sure.
But it's been a topic. Maybe one of my teammates on the call knows this more clearly, what's been announced and what's not been announced. And if so, please do speak up. But it's an effort that's been underway for a considerable length of time. And I gave a public talk about a year ago about a scheme for this sort of 2 of 3 or style of proving. So it's something we've been working on for a long time, as well as the underlying sort of ZK proving piece.
Yeah, no public timelines have been communicated on this yet.
Thanks, Alan.
Cool. Got it. Thanks, Alan. All right. Well, yeah, I'm not sure that there's much else to say on the topic at the moment. If there's anyone else here, I think some of the other folks that are more active in this discussion were not able to make today's call. I appreciate Ed. Thank you for making the time to come on today's call. If anyone else has anything to share here, we can keep going. Otherwise, maybe we can wrap the call up here. And I'm sure this won't be the end of the 7-day discussion. So we can continue it async, and we'll have more to share on that, I'm sure, in the coming weeks.
Yeah, I'll just add quickly, Josh, I'm happy to work with you on trying to pull in the right people from other teams to try and check some of those boxes that Ed listed. There's a few that we're working on internally. There's others that I think we need a little bit more support and expertise on if we want to try and make those assumptions clear and then raise any sort of disputes we need to about those assumptions and get to a point where we could feel comfortable changing that period. So just let me or Lumi know if there's anything we can do to help herd cats outside of this group or just OCL broadly.
That's great. Yeah, I will definitely hit you up about that. Yeah, I think right now we're in a bit of a position where we're all sort of like standing around pointing at each other a little bit. Everyone's busy and no one is like really has the bandwidth, I think, to jump in and spend the necessary time to do the proper analysis here. But I think with maybe a bit of thoughtful herding, we can get it done in the coming weeks, or at least make some progress in this direction. So yes, and if anyone else has interest, comments, anything around this, feel free to message me or anyone else here. Drop a message in the chat. Cool. Okay. Awesome. Thank you all so much for joining. See you all next time.
Thank you. Bye.